Now that you have seen my credentials, I will begin this report on my most recent work. We're going back to working on ellipse problems. The year is 1991 in the timeline. I am matriculating at Savannah State University, and it is there I conceived the idea of finding an equation for the perimeter of the ellipse that will result in a closed form solution. After conceiving the idea, I put it into computer code and I began to run test data through this code just to try to find out how effective of an idea it really was. Then something went on in the mathematics world that distracted me. The Millennium Problems. It was possible for me to win $1 million for solving one of these problems, and I could not turn away from that. Therefore, I began to try to find a proof for Fermat's last theorem, and that distracted me from the perimeter of the ellipse dilemma. That was the first of the distractions. Later, I began to matriculate at a different university, or institute, Massachusetts Institute of Technology, in fact. And it was there that I began to encounter other distractions, and the distractions just piled on until eventually finding a closed form solution for the perimeter of an ellipse was a problem that was out of my mind, gone by the wayside. However, now, the year is 2022 on the timeline, and I am working in the field of astrodynamics. It is there that I encounter the equations for the ellipse, its perimeter, and a whole lot of other properties of it often. It is these encounters that have sparked my memory of that time when I hoped that I could find a closed form solution for the perimeter, and that is what I am doing today. So what did I do when I approached this problem in 2022 in today's time? Well, I coded the possible solution in Microsoft Excel. And inside that Excel program, I generated data. I analyzed that data and I evaluated it to see if the solution that I had proposed had merit. Well, did it have merit? Not quite yet. But it's not the end of the road. So I started to think about what I could do next. Now I am going to give an expose showing the detailed procedure that I use in attempting to solve this problem. Around the center of an ellipse whose eccentricity was E, I drew two circles. One circle had a diameter that was equal to the major axis of the ellipse. The other circle, a diameter equal to the minor axis of the ellipse. It was my desire now to find a relation between the two circles that would somehow give points that lie on the ellipse when all three figures are evaluated at the same coordinate pair. The ellipse was used to generate x and y values. X was the independent variable, so it was chosen somewhat arbitrarily, and the ellipse would give us the y value. These x and y values would then be used to generate numbers from the circle equations. So through that formulation, I tried to find a direction. So a quick review. I used Microsoft Excel to work with my problem solution. I solved the equations for the ellipse as y equals f of x, with x being the independent variable. And I also formulated the circles in the same way that ellipses are formulated, with one side of the equation being equal to 1. Then I ran some test numbers in this Excel program taken from the first quadrant of the ellipse. That would have been enough, because of the symmetry of the ellipse, to give me an idea of how the whole curve was going to perform. Finally, I analyzed the results to see the value and merit of the approach that I was taking, and I discovered that I was able to get some ideas about what was right and what was going wrong. I was very well directed by this exercise with testing the set of equations. Now we are at the milk and honey of this project, the output of the Excel spreadsheet. We have in this spreadsheet the column for the semi-major axis A, the semi-minor axis B, the independent variable x, y equals f of x for the ellipse, the major circle, and the minor circle. The value for the semi-major axis is 2. The value for the semi-minor axis is 1. And the eccentricity E is calculated from these values as 0.866025. The independent variable x is equally spaced intervals from 0 to 2, the length of the semi-major axis. Dependent variable y equals f of x is generated from these equally spaced values of x. The major circle column contains the formula x squared plus y squared divided by a squared. The minor circle column contains x squared plus y squared divided by b squared. So these are called the major circle and the minor circle respectively. In the major circle column or the minor circle column, wherever the equation is evaluated to 1, then it has been given points that satisfy the respective circle equation. So here at the top of the spreadsheet output, we start with the center of the ellipse and the circles, the point x equals 0, and that generates on the ellipse the value 1, which is the tip of the semi-minor axis. When 0 and 1 as a coordinate pair are substituted into the major circle, it gives 0.25. So these 2 points do not satisfy that equation. But when 0 and 1 is substituted into the minor circle equation, we get 1, which is the correct value. That is why we know that this is a point of intersection between the minor circle and the ellipse. Notice that the y values go from 1 down to 0 for the ellipse that is the range of values that it is allowed to have from 0 to 1. The major circle starts at 0.25 and it begins to move upwards. And it may be going towards something, we don't know. But later on we will find out that it is actually converging towards a correct value. The minor circle value, on the other hand, when it receives coordinate pairs from the ellipse, starts at the correct value and then begins to diverge, as you will see in future slides. Now we are looking at the center portion of the spreadsheet output. The independent variable x column continues to increase monotonically up to about 3/4 of the way to the end of the semi-major axis. The dependent variable y continues to decrease monotonically, while the x squared plus y squared divided by a squared column, the major circle column, continues to increase monotonically, as does the x squared plus y squared divided by b squared column. So the trend that was started in the first rows of this table continues. And now we're at the bottom of the table here. It continues in the same trend until the dependent variable is supposed to be 0 and the independent variable reaches the end of the semi-major axis and becomes 2. However, we didn't get what we were supposed to get at the end of the dependent variable column. We got a numerical error symbol, and that totally baffled me. Couldn't figure out what was going on there. I considered that it could be that the square root of 0 would generate an error, so I tested that in another cell. I set the formula equals to the square root of 0, and I did indeed get 0 as I was supposed to. After that result, I was totally thrown. What could be doing this? It was a mystery. And since y was coming out as a numerical error, that generated a numerical error in both of the other circle equations because they both used y. I thought about the problem for a while, and I did eventually arrive at an understanding of what was going on, and I was able to fix it. We are now looking at the formula area of the spreadsheet, and in it shows the formula that is used to calculate the dependent variable y equals f of x. Now this is the fixed form of the formula. What you're seeing is what occurred after I applied the fixes, but I'm going to tell you what was causing the error right now. If we take away this absolute value function and the square root function and just consider what is inside the parentheses starting from the power of cell B2 raised to the second power, all of that in the parentheses. If we were to calculate just that part, we would have gotten a 0. However, Excel gave us one of those numerically inaccurate zeros where you just get some very, very small number arbitrarily out of the system. I think it was a number to the minus 18 power. But that wasn't the problem. The problem was that number was also a negative number. It was negative 8.8 in some digits times e to the minus 18. And when I tried to take the square root of that number, that is what was generating the error. Excel cannot take the square root of negative numbers. So the fix that I applied was to put that parentheses in an absolute value function, so that whenever the calculation was carried out, it was guaranteed that I would not get a negative number. I would always get a positive number, and thus the square root will be always handed a positive number to deal with, and not possibly get a negative number. So that was the cause of the problem, a negative 0 being generated from Excel calculations. So after applying the fix, the dependent variable now ends on what you could call an Excel 0. It's not exactly 0, it's just that very, very small number. But for all intents and purposes, the major circle and the minor circle considered that close enough to 0 for them to get the right numbers. So when x is 2, and you're at the end of the semi-major axis, y will be 0. And when you plug the point 2, 0 into the major circle, it satisfies the equation because you get the 1 in this column. But it does not satisfy the minor circle equations as we expect. That continues to diverge and you get the value 4.